Good afternoon, everybody. Welcome to the Neo4j Twitch channel. My name is Adam, and I'm a member of the DevRel team at Neo4j. So in the last few weeks, I've been looking at some different ways that you can use Neo4j with TypeScript. Today I thought I'd do something slightly different. I'd look at reactive streams, reactive programming, and RxJS. So RxJS is something I've been learning recently. It's kind of like a new paradigm, a new way of working. And essentially what you do is you work with streams of data or observables and then process them using what are called pipes. So if we take a look at the documentation here, basically what we do is we take a function which then produces an observable, and then this observable can be piped into basically a set of operators. So, for example, in this case, we're taking or using the range function here, imported from RxJS to create a range of numbers between 1 and 200, and then turn them into a stream. That stream is then piped through these different operators. So, for example, the filter operator to get all of them where they're even numbers. And then the map operator there will then basically square it. So x plus x. So 1 will become 2, 2 will become 4, 4 will become 8, etc. And this is something that we have supported inside the JavaScript driver. So it's also supported in the Java driver and the Python driver, but I'll be focusing on the JavaScript driver. So instead of creating a session, we then create an Rx session. So we're calling driver.rx session. And then when we execute the queries, so instead of subscribing to the results or using the promise return, in this case we're taking the using the run method, which then returns a promise, and then once that resolves, we then use the result. So instead, what you do with the Rx session is you call the records method, and what that does is that creates an observable, or returns an observable, which then returns a stream of the results. So instead of calling for each or map on this records array, we then get them as a single value. And then in this case, what it's doing is it's getting the name property from the query. So that's that one there. And then, so with all of the observables, you can call subscribe on there. And then for each of the records that comes through from the stream, you can deal with them from there. And then once the stream is complete, you can then log out some information. So part of this session is, I guess, triggered by a conversation I had with an old client last week, where we were talking about reactive streams, and we were talking about how we could import data and how we could make the imports more efficient. So they were coming from an RxJS background; they didn't really know what how to implement that into Neo4j. So we sort of met in the middle. So hopefully we can do something similar. So today I'm going to look at revisit a blog post that I wrote a few months ago. So I wrote this in January, and it's all about a fictional client called SkyShard. So SkyShard are a travel website that offer cheap flights to its customers. And basically, due to the amount of flights that the website offers and the frequency of updates, there were some problems with the write performance, and also with the read performance as well. So this is loosely based on a client I visited last year. So it's a kind of a real use case. And what we were looking to do was to basically investigate how we could improve the write speed of Neo4j. And basically just make sure that the data goes into the right place, and we can get the best write performance and the best read performance as well. So with Neo4j Fabric, it's called. So it's basically a way of sharding data inside Neo4j for scale. And essentially, what you do is you create what's called like a proxy server, and that sits in front of different databases for each one of the shards. So, for example, if you had I don't know, a photo sharing site, you could shard the data by country, you could shard it by region or by continent, and then that would, in theory, make your reads quicker because you'd be reading from a smaller set of data. You'd be reading from a individual shard of the data rather than the higher data, the whole graph itself. So the amount of data you query essentially is going to be smaller because you're only touching a smaller graph than maybe you would be. So basically, the conclusion for this is basically we would shard by month. I don't know where this is said in there, but basically the decision from the discussion was to shard things by month. So we could then split things out. And then when you're updating data, then you know, in terms of like the locks and things like that, then you're only contending on locks on a smaller basis. So if you're interested in the setup, how this works, and about Fabric, then head over to my blog and you can read this blog post, and it will tell you everything. I'm going to assume that you've read this. If you haven't, and you're watching this on replay, or if you're watching it on YouTube, then pause the video now, go to the blog post, read through before we go ahead. But yeah, so essentially, as part of this, I wrote like a little script which would like just is a Node.js script which would take the data and then split it out into the different months. So then they could be sharded into or inserted into the right shard. So basically, the way this worked is we created a driver, read from a CSV file, which then produced like a stream of a stream of rows essentially, and then we'd then go through and import the month. So basically, the CSV file had loads of information inside there. So there's I think it's 200,000 rows inside there. But then we took the year, month, day, the flight, and the origin and destination, and then basically sharded it out. So based on the month, it will go into a particular shard. So it would be January 2020, February or March 2020. So we'll do the same thing in RxJS, and then insert that into Neo4j. Cool. So in terms of the importing the month, we'd basically have the some data which had been extracted out, which would represent that month. We then take the shard and then we'd insert the data into that shard. So all of the code is up on GitHub. So basically, I'll be using the same, or building on the same code. But essentially, there's this Docker Compose file which will bring up the Neo4j cluster, so bring up the Fabric cluster plus each of the individual Fabric servers for each one of the months. So, like I said, we create this proxy server. So this is based on Neo4j 4.0. So this image is now out of date. So you can just go for Neo4j 4.0.0-enterprise, but we'll go through that. We then create a shard for each one of the, or a new server actually for each one of the months, which is then configured. So, for example, we've got this January image here. So the host name that we give it inside the Docker network is January, and then we basically map the ports to localhost. So 7474 will go to 17474, so we can access the individual shards if we need to. We do the same thing for February, and we do the same thing for March. So the difference between January, February, and March is that March is a causal cluster. So we've got 3 servers there. So we'd have 1 leader and 2 followers. The writes will all go through to the leader, and then be distributed along the followers. So this is really just to demonstrate the idea that we could have a single instance of Neo4j, but in theory, if you're working with a cluster, then there's no difference there. Cool. So I've already got this this running. Actually, no, I've just stopped it. So if I open a new window and go into here, so this is my my clone version of it. So it's a little bit out of date, so it's 181 days old. But I can just run Docker Compose up, and that will load up all of the servers for me. Cool. So that's running. I'll go through and I'll create a new project. So if I will, let's call this Sky Shard RxJS. Cool. So I want to npm init. So I just use Y just to create that new new project. So I want TypeScript in there. And then what I want to do is I want to basically init the TypeScript project. So if I open this up in code, then I've got this this project here. So I've got my package.json file there, and I've got my tsconfig.json. Cool. And what I'll do is, while I'm here, I will copy over the data folder. So this is the CSV file that we'll be working with. So it's a huge file. So it's 327,000 rows long with loads of data in there. So again, it's got the year, it's got the month, it's got the day, departure time, scheduled departure time, the delay, the arrival time. So the things that we're interested in today is basically the date, which we can get from this value at the end. And then the arrival time, departure time, and then the origin destination airports, which is origin and des. So this is an old file, so this is from 2013, but we're just going to pretend everything in this is for 2020. And we can go from there. Cool. So let's see. So all of my servers are now running. So if I do docker ps, so I can see that I've got servers for Neo4j Enterprise, so for March, February, January, airports, March 2 and 3. So that's all of my servers there up and running. Cool. So I'm just going to create a index.ts file in here. And then what I'll do at the same time is I'll create a nodemon file. Cool. So I want to install that as well. I'll say nodemon. I'm just going to copy in a nodemon config file that I made earlier. Cool. So basically, what I'm saying inside here is when I run the nodemon commands, this is basically going to sort of listen for changes in my file. But basically, what I'm saying is for what I want to watch all of the files inside the source folder, and where the extension is .ts, ignoring anything which is a .spec.ts, because I don't want to restart the server every time I change a test. And then I want to execute the ts node command on source and then index.ts. So now if I, for example, console.log hello, so now every time I make a change, the code is recompiled from ts into JavaScript and then run from there. So if I change that to hello world, then we'll restart with hello world there. So another thing I want to do, so I want to install RxJS. So to do that, so from the instructions here, it's just npm install RxJS. That's all I need to do. So that will give me RxJS, all of the operators and the functions that produce observables as well. So I'll just run that. And then I can import RxJS from RxJS. And cool. So basically, I mean, there are some great sources that you can learn more about RxJS. I'm by no means an expert, but I'm working my way through it. So actually, yeah. So some of the sites that I've enjoyed working with so far. So some of the documentation is all over the place, which is a little bit of a nightmare when you're first learning. There's a lot of operators and functions that you need to remember. But learnrxjs.org is probably one of the best things that I've found so far. So it's got a list of all of the operators, so you can kind of find what you're looking for there. So for example, from event, so it gives me all of the information about the operator, and then gives me some examples, some recipes. So that's really useful. And then this advert here, so this is for Ultimate Courses. So this is what I used. So Ultimate Courses is run by Todd Motto, who lives just down the road from me actually. So he used to work in the town that I live in. But these are really great courses. I'd recommend them. I've bought them myself. I'm not being paid to say this is no advertisement. It's a really good resource. So there's also Angular and TypeScript. So if you want to learn those, then go there. But for me, the RxJS, there are two courses: as the beginners, and then there's the masterclass as well, and both are really useful. So I'm sort of halfway through the masterclass at the moment. But yeah, and then there's RxJS Marbles. So if you're learning anything to do with RxJS, then you sort of learn pretty quickly to interpret these marble diagrams. But essentially, given a stream of values, in this case, we've got a stream of 20, 40, 60, 80, and 100. Basically, what they show you is given a value or a stream of values at the top, and then some operators. What will then happen to the value? So say we've got two streams here, one with 20, 40, 60, 80, and 100. And then we have another one which has two values emitted at certain points. The merge operator in this case will take those two observables and then merge them into one. So we then get one stream of 20, 40, 60, 1, 80, 100. And you can sort of move the stuff around to see what would happen. And yeah, so like for example with the concat, we have 1, 1, and then this value here, and then the concat happens, and then we can see what happens there. So that's kind of useful. So debounce. So for example, if we take a timer, and then so in this case, I guess like debounce based on number of times. So only take one click per 10 seconds. Then we'll take the first one, and then we will then debounce. So it'll only take a certain value, which is kind of useful. Cool. So basically everything around RxJS evolves around observables. So you import these from RxJS. So you can create a new observable, and then you can have basically like a subscriber that's passed to that. So you can create a function. So for example with observer, and then we can call like observer.next. So for hello, and then we can do another one for world. So right now this won't do anything. Let's call that stream. So yeah, so this won't do anything at the moment. Nothing happens with that observable until something subscribes to it, and you can subscribe using the subscribe method. So if I call stream.subscribe, I can then pass an observer, which can either be a function, so I could just say, for example, n console.log n, and then that will produce two values out. So I've got this stream of hello and of world as well. So this produces two values. So for example, if I just split that out, let's say next hello and then next world. Or I can supply an object. So I could say for the next value, I can say console.log next. I can also listen for errors. And I can also listen for when the stream is complete as well. So that doesn't give you anything, but you can just log something out. Cool. So this returns me hello and returns me world, but it's not complete. So the stream is there; it's still live in the background. In order to complete it, you call the complete method on there. So that's the stream now complete. But you can basically you can create observables from values like this, or you can use some sort of like helper methods. So the example in the RxJS Ultimate Courses course uses things like like from event. So you can use from event, and you can give a target. So that's anything that could be any event emitter. So for example, you'd have document.getElement by ID, and then we could say, like, for example, my button, and then the event would be click. And then you could subscribe to that. So you could then say .subscribe, and then you could create your, you just add your subscriber to that. Cool. So I'll keep that there, and I'll just move that around for now. Yeah. So basically, you would then so from this event, you could then use the pipe command, and then you pipe into different operators. So say, for example, for each one of those button clicks, I could then take the value. So I could use the map, which is kind of like think of it as like an array.map. So look, from the value, you could take value.x, and then that will give you the x coordinate, or I guess value.target .x. But that's not too useful for us at the moment. Basically, so basically what we want to do is we want to take this CSV file, and we want to pipe the information in, and then we want to insert the data into Neo4j. So I guess with this being TypeScript, it'd be useful for us to create a few types. But basically what we're going to do is we want to read the data from a file. Okay. Actually, so what I will do first is I'll go through the Neo4j driver and the reactive the reactive drivers, and then see how we can use those. So if we take a look at the documentation, so instead of creating a regular session, we would create an Rx session, and then that gives us a wrapper around some RxJS operators, and then we can use the records function from that. So what I'll do is I'll just create another file, and let's just call that neo4j.ts. Cool. So if I stick these side by side. Cool. We want Rx session. So basically, what we do is we would, so the first thing we need to do is to install the Neo4j driver, so we don't have that in there yet. Cool. So again, we'd import Neo4j from Neo4j driver, and then we can create an instance of the driver. So the driver would be neo4j.driver. So I just create this for localhost. Neo4j. Running on 7687 and neo4j.auth.basic. Neo4j. My password is always neo. Cool. So the session would be so we can then call driver.rx session, and this is the same as a session. So we can say that the default access mode is read. Use the proper types there, and then we can do session. So we can either create transactions, which would give us like Rx transactions, or it would give us a we can use session.run, so we can say, for example, like match n return count in. We don't want any parameters. So normally you would have like a dot then. So this will return an Rx result. So we'll take a look at the Rx results. It gives us keys, function, records, and summary. So these all give us observables. Sorry. So basically, we want the records. So if we call .records, then this produces an observable, which has basically one for each record. So we'll get one record in the stream, and then so then we can say, for example, we can pipe that into an operator, and then we can say map. So we have a record there, and then we want basically record.get count. So it always bugs me. Like, just let me write my code. Cool. So if I include that into this file, cool. So now I can do, like, for example, I can use the tap operator. And so I guess one of the things to highlight at this point is that there are a lot of operators. There's lots of things to remember. The documentation is your friend on all this. But basically, the map operator is like an array. So basically, I'm saying for each one of the values that comes through this stream, give me the count from that record. And then like the tap is basically like I guess it's like a debug type operator. So basically nothing happens to the stream as things get passed through. So I can just take, for example, the row and then console.log the row out. Cool. So I can, for example, I could just say export count query. So again, like nothing's going to happen to this stream until we subscribe to it. So nothing has happened in that output there. So I want to import map and tap. So all of the operators are in RxJS/operators. So you can import everything from there. This is kind of a handy place to have it all. So I can, if I import the, what do I call it? Count query. Cool. So I can say count query and then .subscribe. And then, so next, I'm sure I have this. There we go. So import count query from Neo4j .ts. And then we want count query .subscribe. Cool. So it's created a, actually that's still an integer. So basically it's given me inside here, because I've used the tap, it's given me the value out. So if I just clarify that. And then it gives me the record, and then I get the next chord on the actual subscriber, which gives me the count as a number. Just convert that to a number. And then once the stream is complete, so once all the records have been consumed, that stream is then complete, and then we've got what we need. Cool. So for example, if I said, unwind range 0 to 10 as count, return count. So this will just sort of demonstrate that we are getting a stream of results out from Neo4j essentially. So we have like a row for 0, one for 1, one for 2, and then they'll be called with the next action. So if I remove that tap. So for each one of the values that's been returned by the Neo4j query, I've now got that row, so I can use map to then get the values from there. So I could say, for example, like return count and then count down, count times count squared, and then I can return from here, instead of just a single value, I can return an object. So the count is there, and then squared is squared. And then instead of giving me single values now, it'll give me an object, which should give me an object. Cool. So I've got 0, squared is 0, 1 is 1, 2 is 4, etc., etc. Cool. So what I could do is in the stream, I can call like a pipe on this as well, and I can add more computation to that. So I could say, for example, filter. So filter comes from RxJS operators, where the value, let's say we take the row in, so we want where row dot count is more than 0. So I'll give us 1 to 10 instead. So 0 has been filtered out. The first value you get there is 0, which is cool. So that's bringing the data out of Neo4j. So basically, just to recap, you take an RxJS session, so an Rx session, rather than just driver.session, you call rx.session. Then once you have we'll get the data out, you call records, and then that returns you an observable which has the record. So the record is exactly the same thing as you get inside the Neo4j driver itself. And the regular sessions, and then we can just use the pipe function there to pass it through different operators to get our value. Cool. So I'll copy some code into here that I've written earlier. So basically, I just want to expose a couple of functions, which then allow you to interact with Neo4j. So like a read one for read queries, and then a write one for write queries. So this is the original way of doing things. So you call driver.session, then you call session.run. So just so you can see the difference with the read query, this will return a promise, whereas the write will return a stream of records. So this concat operator, so basically instead of calling them on the promise and then closing the session and returning the values out, so basically you call records, which then gives you the observable, and then you call pipe on that, and then you call the concat operator in there. So if we take a look at the where is it? The value here. So if we search for concat, so it will subscribe to observables in order as the previous completes. So basically, it's kind of like a line at an ATM. So the next transaction cannot start until the previous one completes. So basically, what that is saying is once the records have been consumed, then close the session essentially. So that's why there's a kind of a delay. If I refactor this query, to export that first. Cool. Yeah, so once we've consumed all of the rows, then that session gets closed essentially, and then the results are passed out into the stream. Cool. Okay. So yeah, so what we want to do is we want to mimic what we did in, or sorry, what I did in the blog post. So we can take the code and we can refactor it into an RxJS stream. So we want to get the values from the CSV file, and then for each one of those, we then want to filter out so it's into a particular month. So if I create a new file, let's call that flights.ts. Cool. So basically, what we did is we had this read from CSV file, which basically creates a read file stream, which then pipes into the CSV command. So this isn't RxJS, this is just regular JavaScript. And then we, on the data, it would then add the results to this value here. And then it would, on complete, so on end, on the end function, it would the promise would resolve with the results in there. So obviously there's some it's kind of like an eager function. If you think of it as like an eager aggregation in Neo4j. where the results won't be returned from this until they've all been processed, which is kind of a may take a long time, especially with a large file with 300,000 rows in there. It might take a long time to complete. So what we can do instead is we can use RxJS to produce streams of those values, and then we can then use the operators to batch them up and insert them into Neo4j. So like I mentioned earlier, there's this from event operator, also from event function in RxJS, and that allows you to create something or create a stream or an observable with streams from any event emitter in Node. So this is great for things like logging key presses and things like that or like on a website. But basically, what we can do is, because we have this basically the file service create read stream, which is what I used in the previous value, or in the previous version. This actually produces an event emitter as well, which we can then just call from event on to turn that into a stream. So say for example, I've got this read stream, so we can call fs dot create read stream, and then so we want to take this this data, so their name, and then out one directory, so out of the source directory into the data, and then into flights.csv. And then this will return us a read stream. So that's something that we can call pipe on, and we can call, or we can provide that through to an event emitter, or from event. So basically what I can say is I can call read stream.pipe. And then so the destination, so basically what I need to do is to use the Csv Parser. So it would be npm install and then Csv Parser. So basically that's what we need to do. We need to take the take a read stream. So for every line in the file, we can then pipe that through to a CSV function, which will then split it by the comma, and then produce a map with the values in there. So we can import CSV from CSV Parser. So that's just a function, so we can call that CSV. And then that will give us a value. So basically, we want to create an observable now. So it would be an observable. So let's call this read CSV, and that will be an observable. And then it will just basically be of objects. And then we say that is from event, and then from read stream. And then the event that we have, so we can see the event there is data. So on the data command, it gives you the row. So basically what this will do is this will create us a stream of values with each one of the lines. So we can say, for example, we can pipe that into another function, so we can map that. And basically what we want to do is create a flight. So I guess we could create a type or create an interface with flight. So the information that's important to us that we need is the origin, the destination, and then we need the date of the flight, basically. So we'd have the origin, which will be a string. We have want the destination, which will be a string, and then we want the departs out, which we can convert into a date. Cool. So what we can do is, so if we just export that for now, and then instead of doing this, we can import read CSV. And then import that from flights. And we can do read CSV.subscribe. Cool. So that is giving us right now a stream of values there. So what I can do is I can use the take operator to just take like the first one, for example, so I don't get as many outputs from there. So that's the first one. So that's giving me a buffer. So basically, I need to convert that to text. Cool. So I want to take that, and then I want to map it. And I want a function which will return an observable of type flight. So I want to pipe to the map operator. Cool, and I want the origin, which will be, so we want to take a row. The origin will be row.origin. Destination is row.dest. And then, so for the departure time, so we've got this value at the end, so time hour. Pass at will be, so new, we should be able to just take a new date, and then it'll be row.departure. Cast that to be a flight. with me a second. Right, so I'm going to take that just for a second. See what we've got there. So I'll pipe that in. And then, so basically we want for each one of those rows just basically to convert in. Okay, so what we need to do is we have this read stream. So basically what we want to do is we want to create a subject. Subject. So we take a look at the documentation. So a subject is a special type of observable that allows values to be multicasted to many observers. So like event emitters, each subject is an observable and an observer. So basically what we're going to do is create a new subject, and then we want to subscribe to the values that we have there. Cool, so I can say that subject is a new subject. Oh, that was it. Something cool from event. Okay, so yeah, so I need a subject. So I basically want to say that I want this, so this read CSV observable, so which will be an observable of flight. So I want that to be from event. And take that from the read stream, so it uses the event emitter, so on data. And what I want to do with that is I want to make sure that it stops once the data is complete. So when we have received the last piece of data, then an event is fired with called end. So basically I want to finish loading CSV from event, so read stream and then end. So I want to run this, and I want it to be, I want to take it until the finished observer has been fired. Cool. So that works. I don't know why it doesn't work in TypeScript at the moment, but it's fine. Cool. And then we want subject. So read CSV. Subscribe. So when something happens in read CSV, we can pass it through to the subject, and then the subject will take it from there. So the really nice thing about this is that I could be consuming records from, or like these record values. I could be consuming them from many different interfaces, many different streams, and combine them into one. So you're just using one RxJS command, which is really cool. So for example, I could take, I could call subject.next, and I could provide a value in there. So that would be like a different flight which came from a different source, and then they'd all be consumed by the same stream, which is really cool. Cool. So basically, I want to create a new observable. So flights, which will be an observable of flights equals. So I want to take every value that's emitted from the subject, and then has an observable, and I want to pipe some values in there. So I want to convert the value. So the value would be basically what's in the CSV file at the moment, and I want to convert that back into a value. So if I just pipe that for now, see what we've got inside the stream. It's fine, we don't care about that for now. Cool, so it doesn't like pipe of undefined there. So that should give us, yeah, it should return us an observable. Really strange. So it's strange, I can't can't take subscribe on something that is undefined, but is defined at the same time. It's just a TypeScript compilation. I mean, am I going mad there? Probably going mad. It's undefined there, right? Right, so that's still a buffer at the moment, so I need to convert that to string. Cool, so that's doing something. So I guess it's not. Oh, that's why. So I need to pipe that into CSV. So that should now give me an object. Cool. So now I can then convert that. So from the row, I now want to convert that to be an observable of flight. So I want to return a value there. So the flights, so that should be the origin, which is row.origin. Destination is row.dest. And then departs at will be so it'll be a new dates with the row dot, what do we call that? Time hour. Cool, so cast that as a flight, so that should all be good. So for now, I'll just do take 3 and I'll take the first 3 rows. So I'm not putting too many in there. Cool, so what next? So we've got EWR to IAH at 5 AM, 5 AM, 5 AM. Cool. Cool. Okay, so really what we want to do is we want to move that up into here. And do the conversion of the CSV file in the CSV stream, basically. So we can guarantee that everything that we pass through is a flight. Never quite know where this one goes. There we go. Try to start. So coming from writing quite like Java, I feel like that's a nicer way to do it. It's not going to let me do that, but okay. As flight is. Cool. Okay. So now everything that we pass through is now a flight. if that runs. That runs okay. That's not a problem.